Hello everyone, today I want to show you the 16 nanometer technology node, and today I want to demo the circuit is this strong-on circuit, and the pre-syn simulation I already run it, and this is strong-on, it's from this paper. Razavi and strong-on latch, and I use this circuit to do the SRAM design. And SRAM array need the pre-charge, need a sensing amplifier, and I use a sensing amplifier. I use this strong-on. Okay, and now I already done the pre-syn, so now I want to show you the layout. Okay, and I already write this layout, and can I discuss this circuit function? And okay, so if the timing is clock is 0, okay, now today the circuit's timing, if the clock is 0, it means these PMOS will open, and these 4 PMOS will open. So if this PMOS open in the clock 0 phase, so this node and this node and this node SO and this P node will become the VDD. And today our VDD is, let's say it is 1. Okay, so 1 volt, and GND is 0 volts. And okay, so if the clock 0 and this tail current will not open, so it means this differential pair will not operation. So now the phase 0 is pre-charge. Okay, let's say phase clock 0 is mean pre-charge. Okay, and then clock will become 1, and if clock is 1, okay, so this PMOS will turn off, and if they turn off, and this node will result, because if this clock is 1, and then today we have these two inputs, they are racing. So if VIP is bigger than VIN, and then this side, the current will be high, and then okay, so this node will become from 1 volt becomes to 0. And if this become a little bit lower, and this NMOS will, VGS will be higher, and okay, so you can see this node previous 1 volt is because the pre-charge phase. So this node and go to this node, and then it's become let me show it. Okay, it will become from 1 to 0, and because this node is previous is 1 volt, and this VGS, because this S node will become lower, so this VGS will become higher. It's like VGS is like G to source, gate to source. So this current will be higher, and it will result this SON become lower and lower, and we have this Vout is this point, and this point, this node will relative higher because this Vin is lower than this VIP. Okay, so now the circuit function I discuss it. So I use this architecture. Okay, it's same with my design. So they also have another comparator design. Like in brief, these two S1, I think it may be is switch. It's the PMOS as a switch. So now we can see. Okay, so now we can see S1, S3, S4, S2. So this is a strong on architecture. So this is in brief, because this topologic, it doesn't have the S2 and S1 to become the precharge, and then this two node is like a equalizer. Okay, so now I use this architecture to do my simulation, and I got a 16 nanometer technology result. Okay, and now I want to doing the posing, and remember, this I use the biggest is 10 fin, and this I use 14 fin. So these three almost is a little bit bigger size, and in the FinFET design, the fin is proportion to the width, and gate length I use 0.016 nanometer. Okay, so this 4 PMOS is the this, and this, and this, and later I will add the another precharge to here. Okay, so and these two is a MOS. This one too is a MOS, and every FinFET it has a 3 gate, 3 poly gate. Let's see, this is poly gate, and this dummy is in my recognize. I think this dummy poly is used as the fake poly. Okay, so it is because in my recognize, maybe this is because the technology drift or a little bit how to say, a little bit shake, and then we use the dummy poly. This is dummy poly, and we use the dummy poly to doing like the poly gate. PO dummy is dummy poly. Okay, so now this two is this latch. So this I will make it become the latch, PMOS, NMOS, PMOS, NMOS latch, and this is today our rule. This is important, and because it is a little bit like the analog circuit, so the offset is important. So offset is important need to concern. So I use Garin to follow up it. And remember, today if the circuit, if the NCH SVT Mac. So today, this is okay. We can change. You press the Q to do the modify the parameter. Okay, Q and parameter, and okay, we can see on and okay. Okay. Now this is not correct because it may have some bug. This EDA tool. So okay, so it doesn't matter. So I just want to show. Press the Q is the previous action. So this is NMOS, main NMOS, and we need the Garin to make it to make the body. You see, NMOS has a body. Body need to pick up this, and NMOS is use a VTSN and and Garin P sub, and remember to use the CPO. Okay, and we can sizing this gate is the substrate Garin gate size is here, and VTSN. Okay, so we can see yeah, this is Garin, and press double click. If you only click one time, and it will change your direction, like 转弯. So we don't want that. So please press double click left, and or you can press enter is also okay. Like enter, and it will show it. Okay. So this is just I want to show how to code this MOSFET, and then this is tail current, and remember it is 14 fin. Okay, so it's very longer. So we can see in the FinFET design, the gate length is very press the K, and we can measure this length. Oh, you see. Okay, and remember if you put the library MOS, remember this is important. This orange line is the main cell. So the main cell, the middle line, need to align with the background purple. It means grid, and every grid is 14.8 nanometer. Oh, you see, 14.8 nanometer. So this is important. Oh, sorry, I have a little shake, but I think it is. I checked the DRC rule previous. So remember, this is dummy poly, and the most important, every almost library component, if you call it, the gate will have 3, and this 3 is real gate, and this is in maybe I'm not right, but I think that is fake dummy. So then we can do if you want to see, please press this visual. Okay, it's some tip for you. And remember, if you want to move this MOS is this, and body, I mean green. Remember, select it and press the M. And if you directly move, it's like this. If you directly do something like this, it's may wrong because of grid. It's made of grid. So please use the M to move what you want to move component. Okay. So yes, use M. And a little bit tips, like if you want to align this cut poly, this means cut poly. Cut poly is used to cut the poly. So it's in brief, CPO is cut poly. So cut poly is important in advanced technology node. So now I want to share this cut poly to this MOS, this differential pairs source. Cut poly want to share it. So how to do that? Press A, and now you need to select it firstly, and press A and click. This is full select, and if you press F4, it will become partial select. You see, this partial select, and now I want to use full select. So press this. This node will align with this node. Okay, so we can see it have a little bit shake. I mean the gate is not aligned, so we don't want that. So please press the CPO, and firstly I use the AF3 can change the A is very useful. Yeah, and then use the cut poly to do the align. This is used for Oh, you see, I select to the this is VTSN, so that is not what I want. So remember, in the NMOS is VTSN, in the PMOS is VTSP, is used as sub. Okay, so like body result, what we want to use is VTSN in advanced technology node. Now press A to the here. I think maybe we don't want that, so press this directly to align with the list. Okay, so now the Shift U is okay. U and Shift U can be used. Okay. Okay, so now what I lack of is this PMOS. So now how can I do that? Let me flow pan it. Oh, so and if you do this, please DLC every time, because maybe here has some error, we need to clear it. So DRC is important when you flow pan it. I think maybe have some error. Oh, you see. Okay. Oh, what the fuck? Mlim. Oh, a lot of error. So maybe I can salute. I can do it. Maybe no. Let me think how to do it. Press M to separate it and do the DRC again. Wrong DRC. Oh, so big. So how to resolve it? I think firstly we can solve it from the CPO is easy to do, and everything we can see how to resolve it. Oh, maybe it's this part we have some error, so we cannot do it correctly. Let me think how to do that. Cast poly. Maybe this. Don't select, and this, and M1. Remember, don't make it off grid. So it's ugly. So how to do that? This is PMOS, this is NMOS, and this is let me see. Okay, so this is PMOS, and this is NMOS, and this is what's this? Oh, why I need that? Also, maybe this is a problem. Yeah, this is NMOS, PMOS, and this is NMOS. And check the fin number. This is my design. I use 4 fin, and this is also 4 fin. Yes, 4 fin. Okay, so NMOS. Oh, maybe something I click is from create and gathering, and I mistake is I use a wrap, WRAB, to flow it. So maybe this is no function. Let me check. Oh, so what's this? These two things is no function, I think. Remember, don't directly use F2 to save because I need to check. This I think is PMOS. PMOS, and I think this is MOS. Yes, these two MOS, and this is okay. I think now it will become correctly. Oh, don't use that. Let me think how to do it. I use this and poly. Use poly. Okay, so now difficult a little bit. Okay, slide this and maybe this, and this will come and run the DLC again. I think maybe have no error because I mistake it. Sorry. So now I run the DRC and maybe also have an error. What's the problem of this? PP, so we select the PP only. Let me see. Oh, maybe it's NP and PP problem. NP and PP. NP is the P+ implementation, and it cannot be overlap. So, how to do that? I think maybe make the NP a little bit and first check the grid. Oh, you see off grid, so it's also an error. So we cannot do that. So okay, back to here and use M to do. Please use M, not directly use the A. I think don't use the A. M. Okay, poly. And use the poly and directly use the N+ implementation. And we can fix this error. And how can I do? I think sometimes it's difficult to select, but you can use A to this, and remember use the flow select. And if you want to check whether it's you see move on. So we don't want. Okay, so it's already up. So these two cannot be overlapped because P+ implementation is P+ and N+ implementation is N+. So please use a partial select and use this, and then this error will be clear. And remember the P+ implementation, N+ implementation, and because this is NMOS need the N+ implementation, so this is also NMOS. So this N+ implementation can be overlapped a little bit. Okay, so let's see. Now I am doing the flow plan, and later I will do the M can later do, because later I will do the routing. Routing is about the metal problem, so metal area later will be more, so it's not no problem. So tired. So, oh, it also has error. Why? CPO, let's see this CPO. Oh, it's also have, it's also off grid. So how can I do? I think maybe it cannot be shared. So use this. I think now is I only can do this. And okay, now it doesn't have a off grid. Oh, it also have off grid. Why? Let's check. Oh. Maybe use the N to press it. Why off grid? M. Off grid. Why? I use the M. I think this is a near list. Okay. So it's okay, it's okay. And CPU problem, let me think how to fix this. This is P plus implementation. So P plus and N plus. Oh, you see overlap. So we don't want that. So please check the overlap problem. I remember this also have problem because later I will for the poly gate and dummy gate. So and press A and press this. And remember, if you press the A, don't select the whole thing. Because if you use a partial select and then you use the A, you already for this, select this. And everything will also move up. So that is what I don't want. Oh, you see, I move up. So I think this. VTSN, oh, so maybe VTSN can overlap because here it doesn't show the VTSN problem. So how can I do? Oh, damn. So you see all off grid, so I don't want that. Then how can I do? I don't know. So maybe the fixed problem is use the Q and implementation of, because this is N plus implementation of it, and then directly draw by ourselves. So it's really hard work. So I think from, let's see, open the OD poly gate. I think here has some problem because it cannot. I don't know this whether it will error or not. Okay, so maybe let me think how to do. Okay, so maybe later I will do the OD. So let's see in here whether I have the N or okay. So maybe use this. I want to copy and paste. Oh, here has and shift. Oh no. Shift and shift. And copy from here to okay. Why? Oh damn. So shift. A little bit difficult. Why I cannot copy? Okay, so maybe up has. I use the A to directly to here. Oh, it also has a little bit too short. So how can I do that? Do I think directly move? Okay, so I don't know. At this point, I need to use poly or dummy poly. I use oh damn. Later, if it has error, then I change to the dummy poly. So I think the layout, the tip is important. Arrow layer. Why is called arrow layer? Okay, I don't want to stop in here. Okay. Maybe this and A and here and okay, great. And F2 to save it. And remember the unplus implementation, I need to freeze because QuickPlus implementation is here. And I need to let's see how these modes can unplus implementation is more than. Let me check how long. Okay, so okay, maybe I stop to here. And I can, okay, maybe I quickly do the unplus implementation and I stop. I want to go to bathroom. Okay, 43. And click K, imitate it, user 43. 43, okay. 43. Okay. And remember it's n plus implementation, so I think I need to place the 43 in here. So dummy body stop it and cut. Oh, not L. Sorry, it's K and 43. And okay, and use the R to select it. Oh yes, yes, baby. Oh, I remember. Sorry, here has some error because I need to from here. I don't know. Oh, you see, it's error. So I need to do again the K from here. K, and from here to here, and use the R. Okay, it's right. Because this is a mouse, right? So I need to is this overlap? I don't know. I see. Okay. I really don't know. So maybe use the A to, or maybe it has an error and then we can see. But now here need to become 43. So this side, I use the partial select and A and here and here and check another side. Oh yes, it's okay. So and run the DLC. Okay, let's see the conclusion. Let's see the result. Oh, this also has an arrow. So, but it's more. What's this? Oh, I remember. This is VTSN need to more than 0.32 or something. You can check from here. Maybe use the K. I remember the rule is, yeah, you see. And imitate is 2 8 and 3 7. And check CPO, and we need it become 37, right? And cut poly. Why here has arrow? The rule is what? I want to check. Or maybe source is connected to the. Is it? I don't know. Maybe this later I will solve it. And what's this? Okay, so maybe I stop from here and later I will do it later. Okay, thank you for watching.